The most important question in the energy industry right now is one almost no one has credibly answered. How much are AI data centers willing to pay for electricity? My guest today, Hans Royal, has the answer. And if he's even close to right, the forward power curves are wrong. Project finance is missing a once in a century build out, and the correction won't be orderly. This is Hans Royal. Hans Royal, welcome to the podcast.
Thanks, Peter. Good to be here.
So you have something called compute heat rate. It's really making waves lately in the market. Tell us about it.
Yeah, thanks. So the compute heat rate is a metric that really measures the price tolerance to pay for electricity of an AI data center. And as we know, data centers are being built in unprecedented fashion, especially in the US and across the world. Load growth, for the first time in decades, right, in the US. And I started doing some research on business models and on data centers and on the conversion of electricity into tokens and electrons into tokens, which is essentially the innermost loop of this entire boom, right, is converting an electron into tokens. And in that research, I realized there wasn't a metric to specifically measure the economic conversion of those electrons into tokens. And I was like, that's interesting. Why isn't there a metric? And I searched and searched for a specific metric that measured that, similar to, and that's where I borrowed the name from, the gas heat rate, right, which has been used for a long, long time. And so I decided to create the metric because I found it honestly useful in my own research and looking at business models and economics of data centers and energy and all of that. And once I discovered that there wasn't a metric, of went down a series of rabbit holes to research. Number one, okay, can this be measured, right? Like if I wanted to create a metric, can it be measured using public information, et cetera? And then number two, if it can be measured, is it valuable to measure? Do people care? And I didn't know the answer to either of those when I started out, but decided to spend nights and weekends sort of just researching this for fun because I was interested in the topic, and then decided to, design the metric, started measuring it. And then I had this sort of, for a better part of about a year now, kind of working on the research. And then in February, once I sort of had a good draft of a research paper and a series of articles, I decided to put it out there and sort of share it with the marketplace and kind of see what happens. See if question number two, is it valuable, could be answered. And I just want to be, potentially part of the solution, as we do have this issue or it's not even it's not a problem per se. It's an opportunity of load growth in the United States and the impact that these data centers may have on electric power markets, et cetera. And so published the research in February, and ever since I've received really positive feedback. I've written a series of articles about the compute heat rate and how it may impact different segments of the market, et cetera. And the feedback's been really positive. So that's kind of where we are.
No, super cool. That's a great summary. And I think about it like, okay, everybody's looking at data centers as just large loads, right? And maybe people think they're a large load like any other large load on the system. But based on what you found, how would you say data centers may be different from other large loads in terms of their decision making as far as either curtailing or thinking about where they want to build, and what the value of electricity is to them?
Right. And I mean, I think everybody knows it's no secret that speed to power is the name of the game right now, right? And it's been that way for several years, but it's getting more intense, in the last 6 months, year, 18 months, et cetera. And so in that, okay, that's important. Of course, data centers need access to lots of power as soon as possible, can't wait for interconnects, et cetera, need to build as fast as possible. But of course, in sort of researching this and looking deeply in it, once those data centers are built, the question becomes, do they behave like every other large load or not? And that's what the compute heat rate can kind of help explain, which is, well, what's the economic value to the data center of converting these electrons or these megawatt hours, kilowatt hours into tokens? And this numbers are pretty staggering if you look into them. The compute heat rate on the blended average is something north of $6,200 per megawatt hour as of my last iteration of research. And the interesting part is not only is that, 127 times the gas heat rate or the average sort of price of electricity in most wholesale markets. But that number actually keeps going up over time, not down, which is a little bit counterintuitive. What that means then is, from just a raw economics perspective, an AI data center does not voluntarily want to economically curtail themselves until the price of power goes above, in some cases, the statutory limit, in these markets, right? So, like, they do behave thus differently from an economics perspective versus industrial loads. Industrial loads of various types, like an aluminum smelter or a steel plant or other, industrial processes, may decide, hey, energy prices are too high. They're $80, $100, $150 per megawatt hour. We're going to go ahead and shut ourselves off. We're going to curtail, and we're going to send, hey, shift number 2, you go home tonight. Okay, shift number 3, you're going home. And so this is sort of this natural demand side break that has existed in the power markets for a long time. Well, data centers don't have that same economic signal, at least the AI data centers that are converting those electrons into very, very high, revenues. And so as measured, that compute heat rate break even point is in the thousands of dollars. So, an order of magnitude or two higher than current energy prices. And so they just don't economically curtail like other industrial loads do. And so what happens is, imagine a scarcity event when power prices spike in a particular wholesale market. A bunch of industrial loads may decide to curtail and typically, provide some supply demand balance in the market. Well, if there's a critical mass of data centers everywhere that start to dominate that local area, the node or the hub in which they're located electrically, they may not curtail in those intervals, right? And those scarcity events may last longer than they ever have before. And so that's what we're trying to measure and understand a little bit better, the impact of that sort of new demand class and how they behave differently than other industrial sectors.
Totally makes sense. And so let me double click on this profitability metric. If I hear a number like even say $3,000 a megawatt hour, something like that, and they're able to pay that much, that tells me that they're making a lot of money on the back end from that. So that electricity's coming in, it's running through their servers, the servers are being turned into producing compute or tokens, and then they're selling those tokens to an end customer. Did you sort of follow that entire value chain through to arrive at the compute heat rate number?
That's right. Yeah. So just using publicly available information on API, token costs, pricing of different models. I mean, certainly number one, not all, data center loads are the same in terms of their CHR. And it ranges from, on the very, very low end, if you look at sort of even training runs, but more so commodity inference and, sort of cost leader or loss leader type AI inference loads. At a minimum, if you want to be really, I try to be really, really conservative on this, right? On the measurements of these. And you get into, $250 to $500 per megawatt hour sort of equivalent at a minimum. And that's to be like very, very conservative. As I mentioned before, the CHR, the compute heat rate, seems to keep going up over time on average, which was interesting to me. I did not expect that. I expected it actually to go down since I started the research, but it's gone up. The frontier inference is on the other side of the spectrum. So you have like kind of commodity inference or training runs down here. You have frontier inference. So the latest would be GPT 5.5, right? That just came out. 5.5 actually doubled its API costs, right? And so the frontier inference went from GPT 5.4 class or Claude Opus 4.6 was around $54,000 to $70,000 per megawatt hour equivalent, right? So very high. That actually went up to in the hundreds of thousands of dollars per megawatt hour equivalent after the new frontier models just came out, or at least GPT 5.5. So what I'm trying to do, of course, is take all the inputs, all the revenue, and normalize it to, I put a sort of standard 30% margin on the calculation in the formula. You can read it on computeheatrate.com. I'm very transparent about the calculations and how I arrived to that. But essentially, you take all those different variables that are public, API, revenues, et cetera, average costs of the shell and of the infrastructure, et cetera, CapEx, OpEx, and then you end up with, and use algebra, honestly, just simply to back calculate what the per megawatt hour equivalent would be of the price, the break-even point of electricity, right? And so that ranges from, like I said, between 500 or say $250 to $500 on the very, very conservative low end, if you stress the model and try to like get the number as low as possible, up to in the $75 to $150,000 per megawatt hour. So I use then a blended average. Of course, this is going to depend on the specific facility and the specific market and what types of inference are those facilities actually literally running. What I tried to do is make some assumptions about a blended average of those different, training loads and inference loads, and be conservative about it. Honestly, I think the true number may be higher than even my calculations suggest, but trying to be very conservative. It's still an order of magnitude or two above the wholesale price of power, kind of no matter how you slice it, which is sort of the eye-opening conclusion, I guess, that I'm making, through this process.
No, absolutely. So let's say I'm Anthropic and I've got Opus 4.7. Would that be frontier inference in your mind? So I've
Correct.
got data center set up and I've heard that they want to be near metro areas. They don't want to be out in the middle of nowhere. I guess that's because the people using it, they want to be close so they don't have latency and whatnot. But okay, so let's say I'm them and I have a data center. I'm paying for power and I'm paying $1,000 a megawatt hour, some crazy amount, right? Now I'm taking that power in my data center and I'm running inference. There's people in the end, there's people with their computers, with their laptops, with their phones that are going on to 4.7 Opus and they're submitting queries into it. And then it's running that and returning it back to them. So I guess the revenue comes from, I pay $100 a month for Claude Max or 200 because I use it constantly and I run through my tokens. And I know, the people doing development are running through gobs of tokens. I mean, that's why a lot of them are using, say, some of the open source models and trying to, open Claude with Mac Mini because developers run through an insane amount of tokens. And there's the whole concept of token maxing. You have companies like Meta that are actually incentivizing their programmers to use more tokens. So in the end, is that where the revenue is coming from? I'm trying to, for the audience, like paint a picture of, okay, you're telling me they're paying these huge amounts for power. They're willing to, like, ultimately, their own revenue has to drive that.
Yeah, absolutely, absolutely. And look, I want to definitely clarify kind of the difference between the willingness or the theoretical economic break-even point of running these
Right.
inference loads versus the reality of what they're actually paying
Of
for
what
power.
they're paying. Oh, yeah, they're paying way less. So we're gonna get into the why the forward curves suck and why, power producers aren't making that much money right now.
Yeah, so and so yeah, that's one of the sort of common questions I've gotten on the compute heat rate. I'll just want to differentiate what it's not. It's not saying this is what the energy prices are or should be or will be in the future. It
As
actually
power
represents.
producers, we can only dream, right?
Yeah,
Because we're at, the reality is we're at $50 a megawatt hour, very low numbers in the ERCOT these days.
right. The CHR represents the theoretical ceiling for power, right? The
Yeah.
theoretical point at which the data center themselves would economically decide to curtail because the economics of converting those electrons no longer are profitable after a certain point. And so essentially, yeah, it's a ceiling, not a floor, but it does tell us, the direction certainly of energy prices. And again, like I mentioned in those scarcity events, when you do have price spikes in markets, that those events may last longer without the curtailing of electricity, at kind of lower prices. So, um, but I think your question on, well, remind me your question one more time.
No, it's like, I want, so here's what I'll tell you where it's coming from. I hear from all the time from guys from the power industry. I have a power background, so, right? So we're talking about this and everybody's like, oh, it's a bubble, like all this stuff. Why are they building so much of
Yeah,
this?
yeah.
Why are they building? And also on the power side, you see stocks like Vistra, NRG, just running through to the moon. Essentially that's signaling that power prices should be going up, right? Because these guys own power plants and they can't build them that fast. There's a shortage of gas turbines. So the public markets are saying, okay, Vistra, NRG, Constellation, these companies that own power plants, they're not building that many more plants. So the only way they can make more money is if power prices are headed up, right? But on the other side of that, you have forward power prices, forward curves. When I talk to the traders, they're like, "Oh, the market's soft. Like our prices are down. We don't, we're not having. We don't believe that prices are going up." So you have this complete disconnect, and
Yeah.
the people in the power industry, I don't think understand really how data centers make money. I think that's the bottom line is they don't get it. They think that it's all fueled by speculative investment, but I'm I'm always preaching like, look, every time you bring up your phone and run a query and Google now pushes you into Gemini versus the regular Google, that's 10 times the electricity. And guess what? All of us in the industry are early adopters. So there's, you know, 5% of the people don't even use things like Claude Project and the most advanced
Yeah.
stuff. So like, and that's going to be coming to the masses. So my point
Yeah.
is, no, I don't think we're in a bubble. Like, sure, market's correct, but like more and more people are going to be using this stuff and it's going to drive revenue for these companies.
Yeah, I agree. And look, ultimately, so I wrote a piece on this, which is essentially the bubble bet. It's called the bubble bet, but it's basically saying, look, it's true. The stock market in various ways, including Nvidia's valuation and many other AI companies and their private markets and private equity and et cetera, the money being raised and the capital being committed on the one hand, and then like you mentioned, some of those energy stocks are essentially saying AI is not a bubble. Like Nvidia's valuation says AI currently is not a bubble, and so investors think that. On the other side, you do have power markets that seem, at least forward curves in various areas look normal, and they don't look like there is this disconnect. And I wrote an article on
What
that just
stunk?
because
We're reading, okay, all the guys are coming from Northern Virginia. They're all coming to Texas and they're building, 100 gigawatts of power, right? The market's down from year over year. It's soft, like prices are down and we're depressed because we're not making any money. Like it's completely disjointed from reality. I don't understand it. And the only thing I've seen that somewhat explains it is this compute heat rate concept, that the way they measure the forward curves don't factor that in at all.
well, yeah, far be it for me to explain kind of how these third parties are measuring the forward curve and how they're estimating future data center build outs. But I think there is conservatism baked into those models where it's like, all right, we're seeing these numbers, we're seeing these post SB6, interconnect requests, et cetera, and they're really high, but we don't think a lot of that infrastructure is actually gonna hit the grid and actually be built. I'm skeptical of that. I think data centers will connect as soon as they possibly can. And yes, there's an interest right now or a need or just by default to build behind the meter generation, but really these data centers want to be connected to the grid. It's the most reliable power source. It's how to actually most efficiently operate their facilities from just a electrical perspective. Like they want to be part of the grid, not in these islanded behind the meter
They
solutions that are, by the way,
absolutely
way
want to
more
be part
expensive
of the
anyway
grid.
than grid power. Right? Like
I
it's
mean,
almost proof positive of the whole thing. Like if you're willing to build your own behind the meter microgrid own little grid there, which is twice or three times the cost of energy on the grid, that shows you that they're willing to pay way more for energy and they just need it as fast as possible. And once the grid does upgrade and they can hook on, they're going to do so. So a couple other things, right? I do hear this sort of somewhat of a misnomer that, wow, these data centers or these AI companies are not profitable, et cetera. It's like saying Amazon's not profitable in their first 10 years. Like that was pretty intentional. They're investing in infrastructure. And so maybe they're operating in net operating loss, but their valuations are skyrocketing. And by the way, their revenue is skyrocketing too. I mean, what did Anthropic just announce? 30 billion ARR now, or is it 40 now? It's going up 10x per year, right? So this is unprecedented revenue growth. One could argue if there's a bubble or not, but like the revenues are justifying a lot of this build out. And then not only are the literal revenues through, and you asked this earlier, these are both sort of, yes, I mean, OpenAI was targeting individuals essentially. Claude went the enterprise route. So a lot of these revenues are from enterprise APIs, enterprise agentic systems, et cetera. And that's where a lot of this money is being made. And then even when the revenues are not directly API based. Google, for example, just announced in my latest research, this might be dated now 3 weeks ago, but their AI enhanced ads generate 300 billion a year in revenue for them. So, there's real revenues behind this that's driving the economic activity. And so the stock market thinks those revenues are going to, or that committed capital is going to turn into revenue over time. The power markets think those facilities aren't coming online, or at least in mass as much as the stock market does. And long term or even medium term, I don't know that both of those things can be true. And I don't have a crystal ball. Maybe the stock market's right and the power markets are wrong, or maybe the power markets are wrong and the stock market is right, or and vice versa. Right? We shall see. I don't know. I have my own opinion. I'm probably 60-40 that AI is not a bubble, maybe 70-30, something like that. Because I use it every day and I see more and more of my friends and family use it every day, and same thing at work and same thing everywhere. And, Jevons paradox, if you're familiar with that, says the cheaper and more available this intelligence or this commodity becomes, the more and more people will use it, the more use cases. And so that's what we're seeing. That's why, by the way, the CHR calculations keep going up. I'll add one more point to that. NVIDIA announced the Vera Rubin chip recently at their conference. It's supposed to be, 5-10x more efficient than previous versions. What that means, paradoxically, okay, per chip, you get more tokens out per chip. Great. What does that mean for electricity? It means you get 10 times more tokens out of each megawatt hour or kilowatt hour of electricity throughput, which means the electricity is that much more valuable because you create 10x more tokens through that process. So the more chips get efficient, token prices may go down, which is great for everyone. And that means demand for tokens goes up. But the price for electricity, or the value of those electrons going through the chip, creating more tokens per kilowatt hour or megawatt hour, means the value of the electrons goes up, means the CHR goes up over time.
Yeah, I explain that to people, and it's a hard one to grasp because everyone says it's not going to continue because the chips are getting more efficient. They're not going to use as much electricity. No, they're going to want more electricity because they can make more money from every chip. It makes their
Right.
business model more
They'll use
profitable.
less electrons per token, but more tokens per kilowatt hour of throughput.
100% right. So what we have is we have companies that are making a lot of money, and electricity to them, I just say it very simply. Electricity is worth more to them than anyone else and than it ever has been for anybody ever. So as a result, they want more electricity. It's as simple as that.
It's interesting, it's like saying, look, Demis Hassabis recently said that, this AI revolution is 10 times larger than the industrial revolution and 10 times faster. And maybe it's 8 times or 6 times or what, like, what we can argue over that, but in that sort of direction, that's significant. Well, the Industrial Revolution was pretty broad, right? We had conversion of various fuel types and oil and coal and, eventually electricity and like all these different things, converting muscle, oxen and horses, horsepower and human muscle into machines, right? And that was very, very broad. It was a lot of different types of technologies. And yes, there's a lot of inputs into this AI revolution, but they all center around converting electricity into tokens. Ultimately, like, that's the end game. And there's lots of supply chain around that. There's lots of things that need to go into that, materials, et cetera. But ultimately, that's the innermost loop. So whereas, again, I'll just add to sort of Demis Hassabis' quote there and say, yes, it's 10 times faster, potentially 10 times larger than the Industrial Revolution, but also 10 times more concentrated into one particular conversion. And so the idea to say, like, hey, the electric power markets are going to look a lot like the last 10 years as they will in the next 10 years, I think is just doesn't make logical sense to me. It just doesn't. Because we're in an unprecedented environment in the US. And I think it's kind of hard to really understand that until you really look at the numbers and try to calculate what this means. Look, I'm not saying, again, power prices will go to X, Y, or Z in the future. One can debate that. We can discuss it. We can see what happens. But what I am saying is that it doesn't make sense to me to say that the electricity market is not changing. It is absolutely changing in fundamental structural ways because of this unprecedented change in the market.
Totally agree. So, people that own the grid, the utilities, the boring companies, to me, they become, they're growth plays now. And that's why you're seeing the public markets respond in that way. I mean, you think about industrial revolution. I mean, what did railroads do for coal? What did the automobile do for oil? And electricity is fueling this revolution. And I agree that it's bigger and it is more concentrated because in the industrial revolution, there were many, many different types of energy sources that were spread out across a whole bunch of different processes. Whereas here you have everything funneled through one process, which is, electricity converting to tokens. So I couldn't agree more. And the other thing I'll say, and would love to get your comment on, is everybody sort of says bubble or not bubble as if it's a binary thing. And I honestly think both can be true. It could be the biggest growth story of all time and also be valuations could be high in certain areas. And I mean, look, I was right in the thick of things during the dot-com bubble, and if you had bought Amazon on the eve of the dot-com bubble when it collapsed in March of 2000, Nasdaq went down 75%, like from peak to trough. Like people can't even imagine that today, but it went down huge. But if you had bought, Amazon right on the eve of the bubble, you would have made a 10,000x return if you just held it through the bubble and through the next, 15 years. So the point is you want to own these companies, and sure, there can be a correction, but guess what? Like the internet was a bubble, but it turned out to revolutionize all communications in the long run. And I think the same is here. So like you want to own this stuff long term is the point.
Yeah, I would agree. I'd say I was gonna say it's pretty simple. It's like, yeah, there was a dot-com bubble. It was a little bit before my time. I was relatively young during that. But, certainly, the bubble burst, but it didn't mean the internet wasn't valuable. Right? Like it's kind of a laughable concept in hindsight. Of course the internet
It
was
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 so
valuable.
laughable, and I can tell you the old school guys, when the bubble went down, they're like, "Oh, yeah, the internet was just like the fax. It was a
Yeah.
fad." Like, they were celebrating because they didn't want things to change, like, they liked their little moats, but, I mean, it was so obvious to anyone who was paying attention, like, this is revolutionary, and, yeah, valuations came down. Big deal. It doesn't change the fundamentals of the long run.
Yeah, and look, I think I've witnessed the narrative change a little bit about AI. I don't know if you have too in your circles, but about a year ago, a year plus ago, really since kind of GPT came out in 22, and then kind of ever since, there has been this discussion, this debate, like, is AI going to be smart enough to be economically valuable, or is there some like ceiling, or is there like some point at which it just like the scaling laws don't work anymore, and et cetera, and it just will all be in that sense a bubble, like it just won't be valuable to people at all. That narrative has changed quite a bit, I think, in the
Yeah.
last probably 6 months, 9 months. Really,
6 months, yeah, I agree, like, with the most frontier stuff from Claude, like, earlier this year, I mean, for me personally and for people I know that started using it, nobody questions that anymore.
yeah, which is a big change, right? Like because
It's a
that
huge
the previous bubble argument could have been a real bubble. Like, okay, it just isn't very smart and like can't do things very well. If that then was forever the case and technology wise we couldn't solve that and it was never as smart as a human in any area, like yeah, you'd then say, okay, all this capex that's been spent, like maybe like won't be converted to economic value. But that discussion's really changed. And I think pretty much consensus view is yes, it is economically viable. It is still getting smarter, which we're seeing in every single model release. The benchmarks keep being solved. Basically, we need to create new benchmarks to even measure, how smart these things are getting and how good they're getting at economic value driven processes. And so that narrative's changing. And now the goalposts are sort of moving to, okay, well, all right, are there bubbly aspects of this, or are certain stocks overvalued? And that's like fine, right? Like you said before, we can have that discussion all day, and 2 years from now we might look back and say, hey, that stock was overvalued and this one was, and it crashed and whatever happened, right? But in aggregate, like the internet boom, like in 5 years, are we just not going to be using AI at all? Like I just severely doubt that at this point. I don't think that's even an argument anymore really to make.
Yeah, I mean, I think whoever owns the user interface really tells you where a lot of the value is going, and all I can say is personally, after the Claude, I'd say Opus 4.6, I spend 75% of my time inside Claude. I mean, I'm just in there. Anything that I need to do that's complicated, I set up a project and I load context and I communicate with it. And it's like having a very intelligent assistant sitting next to me. And I think one thing that's missed is with everybody working remote, when you have to go get something done as an executive level person and you're like, I need this and I need to get it done and my time is constrained. So, in order for me to get something done, I need instant feedback. I can't wait and like send an email to somebody and have them come back to me the next day. By then, it's like off the radar and I'm not working on it. So, it's creating huge value to me just to have effectively a very smart person sitting next to me that I can get instantaneous real time feedback on whatever I'm working with. So, it's basically taken over my computer at this point as far as almost all the time. If I'm not in a meeting like this or a Zoom call, I'm pretty much working inside Claude at this point. And I just think that's probably going to be a lot of people.
Yeah, and look, I think it's fascinating to look at this. I actually had a chance to meet Ray Kurzweil at an event earlier this week. I don't know if you know Ray Kurzweil, but he wrote. He's a visionary futurist. He's wrote a bunch of books. He wrote a book in 2005 or 2006 called "The Singularity Is Near," where he projected the economic price performance of compute over time and basically predicted things like AI and development and AGI by 2029. And he wrote a sequel just recently in 2024 called The Singularity is Nearer. And basically he was about 85% plus accurate on his predictions. And what he basically says is, look, we as humans have a hard time understanding exponentials, right? We're very linear people through evolution of like the lion is running this way, I'm going to climb this tree and sort of make it in time or whatever, like whatever, right? But AI and intelligence and formerly Moore's law, right? Intel, et cetera, is on an exponential curve, and we have a hard time sort of really understanding that and projecting things forward. But if you look at just in the last year, right? If I look at a year ago, we were at I think GPT still around that model was fine at some stuff. Deep research was a thing for the first time. You're like, oh, I can do some interesting research. Half of it was wrong and like misquoted and miscited. And you're like, well, but it's still interesting that it can do stuff like that. Fast forward right to Opus 4.6 and GPT 5.5, and it's a absolute step change in capability versus the last one just a year ago. And a year is not a lot of time. Imagine what next year, this time, May of 2027, what the models will be able to do if they continue on this exponential trajectory. And we will see. It won't be that long from now. We will hopefully have another conversation. That would be great. And we can check ourselves and look back at this recording and say, did it get smarter and more capable in the last year? And I think my bet would be absolutely in a huge way. And then one can only imagine what kind of value you could get out of having an even smarter model helping you with day-to-day tasks or research or whatever it is you might be doing at work or in your personal
No,
life.
for sure. Like, and to your point on the singularity, like, so a lot of people talk about this, and it's another thing like the bubble that people want to debate. And I think the way I take it away from there is say, look, recursive self improvement is going to be happening. Like, whether or not we get true singularity or not, I don't think matters in terms of the economic value. You're going to have a situation where AI is writing all of its own code. If you talk to the guys from Anthropic, they're already internally it's writing, call it 80% of their code. And eventually, once it gets to 100, you're going to have models essentially self-improving with very little human oversight. As a result, the number of models they can release is going to go up a lot faster. They're going to be able to make improvements a lot faster than they are now. And the other point I'll make is basically from last year's GPT to Claude this year, in 1 year, for me, it's like it's either you use it or you don't use it. It's almost like a binary thing. Like it crossed like a threshold to the point where it's useful. So I say like guys doing research in labs, they measure it in terms of numeric, right? So to them, it's basically a linear curve or a growth curve as it's going up. But for real business people, it's like either it helps me or it doesn't. If it's getting a lot of answers wrong, guess what? I'm just not even going to use it at
Yeah.
all. It's going to slow me down. But now with the way it is, everybody that I show it to that isn't using it, they're like, holy, now I use it all the time. So I think we're very early in that curve. Some very, very smart professionals in all different areas, legal, investment banking, top tier people I've introduced to this and they jump on it and they're like, holy cow, I'm using it all the time now for stuff. So, and I still think it's early days in that. Like,
Yeah, and look to frankly to bring it a little bit back to the economics, just that exact point I think is absolutely true where you can get a teaser, you can get a free subscription to, an open open source, or you can get a free subscription to GPT or Claude or whatever, and you're not going to get the frontier model, or you're not going to get that many tokens in the frontier model. And so folks that are like, well, it doesn't know how many R's are in strawberry are basically like not using the frontier model, and they're not paying for it, which is fine. I mean, it's fine for things like, why does my microwave work or whatever, but for, real cognitive tasks that require some reasoning, for better or for worse, you're going to have to pay for those tokens because they're expensive. It goes back to our discussion on energy and on the economics here. I mean, that's where I think the trend, towards, higher and higher, pricing, honestly, for the smartest models seems to be happening. I'm not going to project the future or predict, but that seems to be happening over time. Again, like I said earlier, GPT 5.4 to 5.5 doubled in price, right? And that's because, well, the intelligence is that much more valuable to people, being that much better and less mistake prone. And then, the leaders of these companies will all basically say and all agree that we're going to be compute constrained for the foreseeable future. A compute constraint means, you know, there's not enough of it to go around. And energy is needed, and energy is one of the main, or if not the main, constraint bottleneck. So if we're compute constrained and we're energy constrained, and you think that energy prices won't be at all affected by that, I just question that logic, honestly.
I completely question it. I mean, I do a little bit feel the only thing it reminds me of is when Bitcoin first came out in the early days, and I was looking at it and I told people like, look, if you understand the way this thing works, the only way the price of this can go up, it can go is up because as everybody continues to print money, like the price of this has to go up. I never could have imagined how much it went up. And we could have a whole nother show about if Bitcoin is a bubble, like probably is in my opinion, but there was no doubt that it had to go up from, 1 cent a coin, right? And so I feel like we're in a similar scenario where you can clearly see number one, yes, these data centers are getting built, they're getting put down, and if you just look at just ERCOT alone, there are all kind of data centers under construction right now. Like not that are just on paper that are actually being built. As soon as they come online, they're going to be taking a ton of electricity. There's just no question about that. And there's a lot more data centers getting built than there are power plants getting built. If you look at the generation queue, and one thing that I think people are really missing, there's a lot of generation in the ERCOT queue that's wind, solar, and batteries that are not going to get built. Like they were put in and they're just kind of stuck in the queue. And then there's a lot of other gas plants that are in the queue that are also not going to get built. So I would say the data center the data centers are moving a lot faster than the power plants are, and there's a very few dispatchable power plants in ERCOT that are actually going to get built and come online. And power plants take longer actually to build than data centers. So you're going to have a lot more data centers coming on, a lot more demand hitting the grid. And you are 100% right because we've had conversations with a number of the folks that are building these data centers. They want grid connections. They don't want to be behind the meter. That's kind of like the phrase I've heard over and over, bridge to grid. They'll use behind the meter, but they want to be on the grid in the long run. So absolutely they are coming on the grid.
Yeah, I agree with that 100%. And look, the other thing is, I mean, even if let's say data centers are planning to be behind the meter long term, well, what does their behind the meter solution look like? You're a gas guy. I'm more renewables guy by background. But essentially the equipment that needs to be procured to actually build those behind the meter solutions are all coming from finite suppliers, right? From a few manufacturers, and those turbines are sold out for many years. So it's not like there's some other magical pool of supply. So every megawatt hour or gigawatt or megawatt or gigawatt of capacity that doesn't get installed onto the grid makes the supply demand problem even worse, right? So like that's also not a long-term solution to the issue that we have.
No, that's right. And for a lot of folks don't know, but just for large scale gas turbines, there's only three manufacturers that are commercialized fully, and there's a fourth, hopefully, that's on the way.
Yeah.
But these guys are really constrained by their casting, right? So that all the parts that they make are mostly made over in Europe by really old companies that can't scale that fast. So they're making investments into the casting shops, but the metallurgy, because these things run at 1,000 degrees Fahrenheit, the metallurgy of these parts inside there is a very much constraining factor, and it's a tough problem to solve. It's really tough. I mean, you could be building more coal-fired power plants, but you're running contrary to your to your sustainability goals if you do that. So it's really just not an easy thing to solve right now.
Yeah, and like you said, I mean, data center development is just by nature a lot faster. The demand side of the equation is a lot faster to be built than the supply side. And so, yes, there are lots of energy companies that are trying to build, as many, new generation plants as they possibly can with the constraints of, permitting and supply chain especially. And, for renewables, tax credits, which were, cut off, by the administration, et cetera. And so incentives going away and the different moving pieces there. It's takes longer and is challenging to build new generation. And so that sort of timing mismatch, in the short and midterm, I don't see an obvious solution to that. And so the result of that analysis would be, well, we'll have more demand than supply for energy for the short and medium term. Long term, I don't know. Like, we could talk about new advanced technologies, fusion, SMRs, etc. We'll see. The sort of most bullish estimates of those things are mid 2030s at best. We shall see. Maybe it happens faster. I don't know. It's hard to see kind of where the supply demand balance doesn't continue unbalanced for the future, unless we get back to our previous question. AI is a giant bubble, and those facilities and that capital that's been committed, the billions, if not trillions of dollars of committed capital, somehow just poof, doesn't hit the grid and doesn't need electrons to convert to tokens.
Yeah, I don't see that happening. You could absolutely have a correction to stock prices. That happens. That's normal. It's a normal process. If I could predict a percentage or when, would probably just be a trader. But just generally, that valuation's correct and the market moves over time, right? But when it comes to the private markets, you're talking about hundreds of funds and trillions of dollars of capital. Like, it's going to continue these data centers are going to continue to get built. I just think fundamentally. So we didn't touch much on PJM specifically, like on what those guys really are saying about compute heat rate. And the reason I wanted to double click on that a little bit more before we go is just, I've thought for a while that the way that the ISO markets, the deregulated markets, have designed their pricing mechanism is flawed, which is causing for not enough generation to be built. And I think that was even previous to the data center boom. You had, and I have nothing against renewables, by the way. I think they provide great value in terms of certain parts of the market. But what you had was renewables being incentivized by the investment tax credits and then coming onto these grids, depressing power prices. So no dispatchable generation was getting built at all. And they effectively price a megawatt hour of wind the same as they do of gas, even though that they're one is always available, one is variable. So anyway, I don't want to throw shade on the ISO markets, but just I'm curious how PJM is looking at compute heat rate, and if maybe if the pricing mechanism in these markets could be altered in a way that would really incentivize more dispatchable generation. Because I think that's the real reason we're in a shortage now, is
Yep.
not only are we getting all this demand coming on, but for the last 20 years, you had dispatchable being underbuilt. So we're not even just trying to build to something new. We're actually trying to catch up to a baseline that we were way below of even before the data centers came.
Absolutely. And the markets need to adjust. And again, you look, no one's to blame. This is unprecedented territory, right? Like, we've been in a sort of pretty stable market for 20, 30, whatever. My whole career, has been pretty stable, pretty flat in terms of
It
load.
was boring, absolutely super boring, and you had, yeah, efficiency and all that. But yeah, I agree.
Yeah. And so, how the market adjusts, will be interesting to see. But yeah, PJM came out with a 70-page white paper 2 days ago on May 6th, 2026 here, called Powering Reliability Through Market Design. And I was surprised and honored to see the compute heat rate, my work cited, pages 49 through 50, if anyone's curious to read it. But in name, really naming the framework as a part of the potential solution in the proposal to market design in PJM. And essentially saying, look, these different types of AI loads have different compute heat rates. And if we can measure the problem or the risk or the economic behavior of these data centers, that's where we can create solutions around it. And so the compute heat rate, from what I can tell in their paper, was used and is being used as a helpful metric to understand the demand side pricing of these facilities that are coming online, especially in Virginia, the largest data center market in the world, right? It's very important for them to get this right. And so they used CHR to actually say, look, if we can measure different types of workloads and different economic price tolerances, that can actually create solutions where the data centers become grid assets. And so, and also then from a supply perspective, if you can get a signal to say, hey, this amount of hours, we're actually going to have prices go up to $500. And then in these amount of hours per year, it's going to go up to 1,000. And we're going to, in these amount of hours, it's going to go up to 1,500, et cetera, based on the CHR of various workloads. That can not only help planning, but it can also help, obviously, supply decide to build in PJM. Of course, there's the capacity market, which has its cap. It's reached the cap the last, right? Like we've reached the cap there. So there's PJM has different proposals. There's a three-pronged, part A, part B, and part C in their paper. I'd recommend anyone read it. It's very interesting, but they do use the compute heat rate to, essentially be part of, a potential solution on understanding the economics and then providing that very important price signal to developers of supply assets, of generation assets to actually build much more. And that's what we need
And
across many different markets.
no, PJM needs it, I think, more than any other market. I mean, I've seen where, a number of plants have disassembled their plants and taken the equipment and moved it to other markets. That's how frustrated they are with PJM. And you've seen things like, the cap put in place, or folks that had projects in good locations that were plants that were running that should be making a lot more money than they are right now are not getting it because they had to scramble and put this cap in to basically make sure that ratepayers aren't paying too much. And obviously, we don't want ratepayers paying too much. And I think you touched on something where, most of the hyperscalers they don't want, bad, let's say, community relations, and they don't want ratepayers overpaying. And they actually are willing to pay more for power sometimes. So I think like treating them like any other industrial load is where I think a lot of these markets are falling down, is essentially, you compare it to a traditional industrial, very price sensitive price. They can't afford to pay prices that are any higher than a very low number. Whereas these new off takers, hyperscalers and others, their economic model allows them to pay more. So if they're willing to pay more, should they not be, able to do that and essentially subsidize the ratepayers to not have to pay more? So
Yeah, which is what the CHR tells us, right? That they're economically willing to pay much more, and that means there's juice in that fruit to squeeze out. And so, yeah, and I think, look, this is no way, shape, or form, laying blame on the data centers, right? This is an economic observation. This is just how the economics work, and you see a lot of leaders in the space, including Google, voluntarily create demand response programs, et cetera, and say we're going to, provide demand response to the grid and these megawatts and gigawatts over time, et cetera, which I think is, good for the public relations piece and et cetera. One of the issues though with that is that not everyone, is set up that way contractually, right? A lot of these data centers are under service level agreements, SLAs, where they actually can't economically curtail themselves because they have obligations to their end customer to run all the time whenever possible to not to 5 nines, right? Like, so there is a little bit of a disconnect between, some of the leaders who are saying, yeah, we can use these facilities as grid assets to, the contractual reality, a lot of the players in the market that really can't do it either from a economic or, not economically driven to do it as CHR proves, but number two, contractually as well. So it's kind of a dual lock that we need to look at, pretty hard and say, how do you unlock that? And yeah, there's regulatory intervention that could be the solution there. It's like, hey, if you want to interconnect in this market, you have to curtail this much. That's what we saw with SB6. It's only for emergencies. So it's not if power prices go to 120, you don't have to curtail. It's only in emergency situations. But that's starting to go in a direction that says maybe there's regulatory intervention that comes in to help solve some of this. But again, regulatory intervention or data center moratoria, et cetera, aren't going to solve the demand supply problem on their own. It actually, in some cases, could make things worse, right? It's sort of like playing whack-a-mole. If you say no data centers over here, they're going to be built over here. And if you say over here, there's an artificial price cap now, can't, power prices can't go over 100 or whatever, then the economic signal to suppliers doesn't materialize and there's not enough supply. And then it's a wider economic problem. It's like saying, how do we stop water from going downhill? It's like you can put a dam there, but are you actually stopping water from going downhill, or will a dam eventually overfill and water will continue coming downhill?
Yeah, no, so I totally agree on that, and this is a national security imperative that we have to win in AI. So there's that whole element of it. I feel like the companies that are building data centers, for the most part, we're actually extremely fortunate to have these companies that are like, I think, benevolent actors that actually care, that are doing this. Like it's pretty great for us as a country, and that's the reason why we have the lead in AI. And it's really the future of warfare, of everything is going to be driven. We could go a whole nother episode on Palantir and all these companies, Anduril and the like, that are basically going to make us competitive on a national security basis long term, and they're heavily relying on AI. So I think that if the US wants to maintain its position that it has, like, is pretty much going to have to win the AI race, and the alternative is not a very pretty scenario. So it's essential we win. It's essential these companies are able to build where they want to build, to have their compute, and we want to build here in the U.S. I think we have 10x the number of data centers of sort of the next country, and we want that to continue. We want it to continue to grow. So anyway, like, and I also will say that I think a lot of the negative community relations stuff, I think, is driven by activism and not very what I would call genuine. I think it's being pushed from somewhere, and it doesn't, to me, seem authentic at all. Because if you drive around Northern Virginia and look at the buildings and look at what is there, number one, they're quiet. You don't even hear anything. The road noise is louder than these facilities. They really just look like office buildings. They're making them better and better looking over time. Like, so, I mean, for example, I personally would not necessarily want a nuclear power plant built, let's say, in my neighborhood, but if there was a data center like a couple doors down, it's just like having an office building. So I personally think the community relations stuff is overblown, and I think it's quite easy for the government to step in and ensure that, mom and pop ratepayer are not overpaying. There's many ways to do that. Whether and there are utility programs that already do that, that subsidize people that can't afford their electric bills. So I just think it's like, a false choice as far as rates and building data centers.
Yeah. Look, I think, there's legitimate reasons to be concerned, but in any sort of, I mean, same thing with the industrial revolution, same thing with, any other, seismic shift in markets or in our world, really, there's going to be positive and negative consequences. I mean, look at what the Industrial Revolution did to the environment, and then, extrapolate that further. I'm a renewables guy by background, environmental. I care deeply, and my entire career has been dedicated to let's like have this energy transition be as clean and healthy for the planet and for people as possible. I think there are real issues. There are real legitimate issues with the environmental impacts of AI and data centers that need to be dealt with. And we've worked with many different data centers on helping them procure renewable electricity over many years. My entire career has been sort of centered around this. But for better or for worse, I would agree with you in that it's imperative that, you know, we win the AI race. And that means in this market, this unprecedented load growth needs an unprecedented amount of new generation. And I think it needs to, frankly, be all things. I would prefer it to be as clean as possible. I'm a fan of, investments in geothermal and in SMRs and in renewables, of course, et cetera. I think it's important for the planet. But I also think it's important that as a country and in a democracy can win the AI race, whatever that means. And maybe there's not a winner and a loser, but it's at least being on the forefront and having access to the technology for all the reasons you mentioned, and just for economic growth and for better quality of life for people. So there's a balance there. I do think if you have a bunch of gas turbines all of a sudden pop up all around your neighborhood that are just blasting the air with like, I think there's legitimate environmental concerns that I don't want to shortchange here. And I would prefer personally that this get done in the cleanest possible way. But that's where we are today. And we just need lots of different types of electric generation. Gas is going to be part of the solution. Whether one wants it or not, you can debate. But Gas is absolutely a huge part of the solution. I think renewables play an important role. And I think the next generation of clean energy technologies will also play a significant role over time. So we will see, but those are
Yeah.
my 2 cents on that.
No, totally agree. And the only thing I'll say is that's why it's important for these things to be connected to the grid. That's why the grid needs to have the right price signal because, really the VPPAs that these guys signed over the last 10 years is one of the biggest reasons why renewables were able to be built is because they were, essentially contracting for this power. So as long as they're grid connected, you effectively use your renewables to keep prices low and you allow somebody like a Google who cares about sustainability to do VPPAs and have, be able to show that they're procuring a portion of their power from renewable sources. So I think, the grid is really the kind of the secret sauce here to make
Hey,
that happen.
domestic energy, including gas and yes, renewables are, among the lowest cost types of assets we could possibly build. And as
Absolutely.
you said, the more renewables that have gotten put on the grid and will be put on the grid, the lower the price for everybody. That's just how the economics of renewable bidding in the wholesale markets works. Prices go down when there's lots of renewables. When it's really windy in Texas, prices go down. When it's really sunny in California, prices go down, et cetera. And so it is part of the solution. I think it's a big part of the solution. It should be a bigger part of the solution going forward. We have a little bit of, we had some incentives that were cut off a little earlier than expected in the industry. But it's not the only solution. You can't just have only renewables on a grid, really. It needs to be part of a mix of many different types of assets. And so that's what we're going to see going forward.
You need it all. So, Hans, this has been awesome, actually. I mean, we're over time and I didn't even notice, which is always a good thing. So, it's really been great having you on. Before you go, parting thoughts for the audience. Is there anything that I didn't ask you that you want to get out there? And how can people get in touch with you and who should be reaching out to you?
Yeah, well, first, thanks, Peter, for having me. It's been a pleasure, fun conversation. And yeah, I guess parting thoughts are, my advice to friends and family on this AI thing, kind of separate from the power markets and the compute heat rate and all of that, is you know, get informed. Start using the tools. Buy one of the subscriptions. Maybe you can't afford 200 a month, but you can afford $20 a month for a couple months just to try it out. Get engaged, understand what the technology can and can't do, and be ready for it to get better. And it's going to change our lives one way or the other versus burying one's head in the sand and saying this isn't going to change anything. My recommendation to my parents and to my friends and family are use it, understand it. And I'm not saying it's going to solve all your problems, but being informed is better than not being informed, just in general. So that's my advice to people. In terms of getting in touch with me, yeah, look me up on LinkedIn. Hansroyal.com is my personal website that has ways to get in touch with me as well. And yeah, I'm going to continue to publish about the compute heat rate if folks continue finding it useful. And I hope they do. And I appreciate all the support. And really, Peter, you've been a great support to me. And so thank you so much for that as well.
No, absolutely. You don't see too many things that are new and exciting that are actually new that are out there. And I really feel the compute eat rate is quantifying something that was really missing in the market. So it's been great having you on and we'll continue to follow it. Thanks, Hans.
Thanks so much, Peter.